Hello grade 7 students. In today's video, we're going to focus on covalent bond. Before starting, I would like to welcome Khalifa al-Mannai. Hello Khalifa, I appreciate your courageous participation. The first molecule I would like to talk about is hydrogen molecule, which is formed from two atoms of hydrogen. First, Khalifa, I need you to predict whether hydrogen is a metal or a non-metal based on its location at the periodic table.
Hydrogen is a non-metal due to the place in the periodic table. It's the only non-metal in column 1.
Great. So, you said all elements at the left side of the periodic table are metals except hydrogen. Hydrogen is the only non-metal which belongs to column 1. Now, let's draw the electron dot diagram of hydrogen. In order to do so, we have to write the electronic configuration first. So, tell me, what does this 1 mean?
That's the atomic number.
Excellent. How many protons does hydrogen have in its nucleus?
Only 1 proton.
Great. And just because an atom is neutral, as it contains 1 proton inside its nucleus, it contains 1 electron in the electron cloud. As hydrogen has only 1 electron, this electron is the valence electron. Accordingly, I write the symbol of hydrogen and just 1 dot. Khalifa, would you tell me, what does this dot mean?
This dot shows the valence electron.
Excellent. This dot shows that hydrogen just has 1 valence electron. This valence electron is located at the first energy layer. So, how many electrons is this energy layer is able to hold?
Only 2 electrons.
Already hydrogen has 1 electron, and still it needs 1 electron in order to have the first energy layer full. Right now, at any time we have a bond between 2 non-metal elements, we have to think of covalent bond. Tell me, Khalifa, in a covalent bond, an atom will gain, lose, or share electrons.
They will share electrons.
It's clear. Each of these 2 atoms of hydrogen has 1 valence electron. So they put their electrons in common in order to have a full outermost energy layer. Accordingly, a covalent bond is created between these 2 atoms. Now, let's move for another element, which is chlorine. What about chlorine, Khalifa? Is it a metal or a non-metal?
Chlorine is a non-metal due to its place in the periodic table. It's in the right side, which consists all non-metal.
Excellent. So, all nonmetals are located at the right side of the periodic table. Now, let's draw the electronic configuration of chlorine. How many electrons does the first energy layer is able to hold?
2 electrons maximum.
What about the second?
8 electrons maximum.
Till now, we've distributed 10 electrons. How many electrons remained?
7 electrons.
Now, how many valence electrons does chlorine have?
7 valence electrons.
What do we mean by valence electrons?
Valence electrons are the electrons on the last shell of the atom.
Great! Look at this electron dot diagram. It shows clearly the chlorine symbol, surrounded by the 7 valence electrons. So, this picture shows clearly that each of these 2 chlorine atoms needs 1 valence electron. So they share their valence electrons in order to have a full outermost energy layer. Now, when each of these two chlorine atoms puts one electron in common, a simple covalent bond is created. Accordingly, each of these two chlorine atoms will have a full outermost energy layer. Now it's time to discuss together how a covalent bond is formed between hydrogen and chlorine in hydrogen chloride HCl. As shown before, hydrogen belongs to column 1. And then, how many valence electrons does it have?
One valence electron.
Similarly, chlorine belongs to the column number 7. And then, how many valence electrons does chlorine have?
It has 7 valence electrons.
When chlorine has 7 valence electrons, how many electrons does it need in order to have a full outermost energy layer?
It just needs one more electron.
Very good, it needs one more electron. As for hydrogen, it has the valence electron at the first energy layer, which will be full when it contains 2 electrons. Accordingly, how many electrons does hydrogen need in order to have a full outermost energy layer?
It just needs one more electron.
Excellent. How do you predict hydrogen and chlorine atoms will react in order to have a full outermost energy layers?
They will share electrons.
When each of chlorine and hydrogen atoms puts their single valence electrons in common, hydrogen will have 2 valence electrons and then a full outermost energy layer. Similarly, chlorine will have 8 valence electrons and then a full outermost energy layer. Thank you, Khalifa, for this lovely participation.